Okay, this is another perimeter question with, again, another twist. So we have a rectangular lot that's to be enclosed by a fence. So we have this rectangular lot enclosed by a fence. However, it's divided into two smaller lots by a fence parallel to one side. So I could draw it like this, or I could draw it like that, whichever you prefer. I'm just going to stick with this one. Okay, now we want to find the dimensions of the lot which will enclose it to give the greatest possible area. That's max area. If 120 meters of fencing is available. So this is the answer, so I'm using that for my isolating equation. So let's label what we have. We have a width, a width, a width, an entire length, and an entire length. So for my isolating equation for the perimeter, I'm going to need a width, a length, a width, a length, and then another width here to divide it into two sections. So here's my equation. I'm going to have a width plus a length plus a width plus a length plus another width, and that will equal to my 120 meters of fencing. So altogether that is 3 widths plus 2 lengths equals to 120. Okay, so now looking at that, I want to isolate for one of my variables, and it doesn't matter which one you isolate for. So there isn't really a better choice, one better choice than the other, but I think I would rather divide by 2 than divide by 3. So I am going to subtract 3w from both sides. So I'm left with, let's move this down a bit, I'm left with 2L equals 120 minus 3W. So I'm going to divide everything by 2 to get my length by itself. And I'm left with the length equals 120 divided by 2 is 60 minus 3 divided by 2, 1.5W. Okay, so now that I have my isolating equation, I want a greatest possible area, which is a max area. So my maximum area being length times width. So I can't have two variables, that's why I use my isolating equation. So instead of length, I'm going to use 60 minus 1.5W, and I'll multiply that by W. So let's apply the distributive property. I'm going to have 60W minus 1.5W squared will give me my maximum area. So what I'm going to complete the square for is negative 1.5W squared plus 60W. So even though there is a decimal there, the process is still the same. I take what number is in front of my variable squared, negative 1.5, and I'm going to factor it out. So negative 1.5W squared divided by negative 1.5 is just W squared. 60W divided by negative 1.5 is negative 40W. Okay, and if you're ever unsure if you've done that right, you can just distribute that back in to see that it actually works. So I'll take my W squared here, I take my negative 40W and split it into 2 equal pieces, and then I'm going to factor by GCF. So the greatest common factor of this row is W. The greatest common factor of this row has to be negative 20, the leading coefficient. The greatest common factor here is W, and then I take out the leading coefficient, which is negative 20. I always like to do a check. W times W is W squared. W times negative 20, negative 20W. Negative 20 times W, negative 20W. So I know I've done that correctly. So I'm going to do negative 20 times negative 20, which will be positive 400. So inside the brackets, I add 400 and I also subtract 400. The reason I subtract 400 is because 400 take away 400 is 0, and you can add 0 to anything without changing its value. So now let's factor my perfect square trinomial, which is right here. And I know from my grid it factors as W minus 20 times W minus 20, or W minus 20 squared. Now, I still have that negative 400 inside the brackets that I have to get rid of. So to take it out, I'm going to multiply negative 1.5 times negative 400, and I get positive 600. So that's what comes out is positive 600. So let's state our vertex. Opposite on the inside, same on the outside. Remember, when it comes to your vertex, the y-coordinate or q-coordinate is what the max or min is. The x or p coordinate is when the max or min occurs. So what it is? Well, that's my maximum area. So my maximum area is equal to 600 meters squared. Now, when does it occur? Well, we used all W's, so it occurs when the width is 20. Now let's go up here and figure out what the length is. So the length, remember this formula here? Length is 60 minus 1.5 W, and W was 20. So I'm going to have 60 take away 1.5 times 20, which is 30. So my length, 60 take away 30 is 30. So I'll go back down here and I'll say that my length is 30. Let's put some units on there. And let's look at the question all together. So it says, find the dimensions of the lot which will enclose the greatest area possible. So this would be the greatest area possible, and the dimensions would be 20 by 30.